Hello students, so let's try to solve one question from TIFR, and this is from the quantum mechanics, and this is really very wonderful problem. So let's try to solve this one. So what is this? One wave function is given, and in this wave function there is some normalization constant, and one part is e to the power I px upon h cut, and another is Gaussian e to the power minus x square upon 2a square. So what we have to do, we have to calculate the average of kinetic energy of this particular wave function. So let's try to go for how we will proceed this one. So students, in general, most of the students will just go for writing the expression of kinetic average of kinetic energy, and you can solve it. But it will take a lot of time. I will just try to solve it from the different concept. So let's try to go for this one. So in general, what you will do, you will solve this problem with the average of kinetic energy, and that is from minus infinity to plus infinity, that is psi star minus h cut square upon 2m del square psi del x square dx, and you can get the answer, and you will easily find answer is A. But here you have to do a lot of calculation, lot of integration, but I will just avoid all this thing, and what I will do, I will just try to see these two wave function independently. So here e to the power I px upon h cut is the wave function related to free particle. So what will be kinetic energy associated to this? So kinetic energy associated to this is what? P square upon 2m. We all know if your wave function e to the power I px, then it has kinetic energy p square upon 2m. Now the another part of wave function, which is basically Gaussian, and the Gaussian wave function is related to harmonic oscillator. And we all know, if my wave function is e to the power minus m omega x square upon 2h cut, then the total energy is basically average of total energy h cut omega by 2. So if we are going to compare these two things, then what will happen? E to the power minus x square upon 2a square is going to compare with e to the power m omega x square upon 2h cut. So what is value of omega? We can get the value of omega, and you can just compare m omega upon h cut is 1 upon a square. So omega is h cut upon m a square. So this is my omega. And what will be total energy? Total energy h cut omega by 2. And what we know? We know the kinetic energy for the harmonic oscillator. The kinetic energy of the harmonic oscillator is exactly half of the total energy from the virial theorem. So what will be that? So we can easily write this value is h cut omega by 4. And now we can put the value of omega. So once we will put the value of omega, then we can get the answer. And what will be that answer? This value is p square upon 2m, and that value is h cut square, and h cut is there, so h cut square upon 4m a square. So this is the answer, and you can get the exactly same answer when you are getting this one. So what is the idea? Idea is that when you have two different type of function, and you can just see the effect of these two functions separately, then obviously eigenvalue can be just go for the addition of this one. So here I have visualized that this wave function related to 1 degree of freedom, this wave function related to another degree of freedom, and if two wave functions are related to 2 different degree of freedom, then obviously the energy eigenvalue will be just going to add it. And here we are talking about the kinetic energy, and we know what will be the total energy, the relationship between total energy and kinetic energy for the Gaussian wave function or for the harmonic oscillator, and we can get this answer in just one line. So this is a wonderful trick that you can use this type of problem. So otherwise you can just go and solve it, and you have this particular integration also, and you can get this answer also. Thank you.